Good evening, Dr. Sanders. In this video, I shall be demonstrating my group's uh, code for the cell shading, where we're supposed to add shadow and wait, we're supposed to render outline and also add like the silhouette part. And so I will run this. I think it's yeah, thing is set, and so I will run this. And as you can see, it may be broken because there's broken lines because some of the faces here are different, but it's pretty consistent with the outline tracing along the border. And yeah, we still kept the background the same, light blue. And yeah, here is the outline traced with the silhouettes. And so in the next phase, I shall go over what I worked on. There wasn't a lot that was changed. It was around 27 lines total. Um, most of the things that are in blue were already given to us by from the textbook. And then uh, this was adjusted by team, adjusting the thickness of the line, then everything. And then what I did specifically is, first of all, we have a center vector here, and all the vector values, the x, y, and z values were added. And then this portion of the code is just finding the average from three. Um, so it's just assigning whatever is at center or the average of that center. So like the x average, y average, and then the z average. And then this one, it's just we're making a float point array called view direction, and all it's doing is it's taking whatever the camera positioning is and then subtracting it with the average of the center values from the vertices of that specific phase. And then, um, sorry, for that specific mod for the model. And then this is just the same thing but for y, and then the same thing for z. So this just calculates the view direction and puts it in a float array. And then in this line, we're initializing a float length, which is just the square root of the x values, the x value squared, y value squared, and z value squared of the view direction, which we calculated up here. And yeah, let's just normalize it. And then here, this is Daryl's, I think Daryl's part, which yeah, just it continues to normalize. So we just calculate the length, which we used in the normalization of the view direction. And then here we also just made a float object called dot product where we multiply whatever is in the normal by the view direction, x value, y, and z. And so when you multiply, like the ray comes like h like this, and then that's like the normal on the face, and then the closer it is to zero. So it's kind of like calculating an angle. The closer it is to zero, the closer the product is to 90 degrees. And yeah, so yeah, there was not much really with this one. It rendered well. It took quite some time, but um, yeah, we got there eventually. Thank you so much, and I hope you have a blessed evening.